Torque. You've probably experienced torque if you've ever tried to loosen a bolt with a really small wrench and you apply a lot of force to it and you just can't get that bolt loose, right? It's just too tough. Well, if you can get a longer wrench, you can apply that same force and you can get that bolt off, right? Because a torque is a force, but it's also dependent on the distance from the center of the axis, right? So the definition, force that makes an object turn around an axis, but remember here, that force is dependent on the distance from the axis, right? So the unit we use for torque is newtons per meter, okay? Now let's look at how we could solve for that rotational torque, that force that we use to move things around an axis, okay? So the formula we're going to use for that, torque, this is actually a Greek T called a tau. Sometimes it's written as a regular T, but torque is equal to the radius, that's the distance from the center, times the force, times the sine of the force that's applied. So let's look at a couple problems and try to figure out how can we take the problems in a homework question and apply them into this equation for torque, okay? So let's say I'm opening a door, okay? Well, a door, that's not a circle. Well, it is part of a circle, right? When I open that door, it's revolving around an axis, a hinge, okay? Let's say I'm applying 50 newtons to open the door. And when I apply that, I'm applying it directly perpendicular to the hinge. So the angle, what would be my angle there? Well, that would be 90 degrees. So that's going to be the angle of the force relative to the central axis, okay? And what's the radius? Well, does a door have a radius? Well, it does. It's the distance of the door. So that would be my radius. So if I plug those in and I say torque equals radius times newtons times sine theta, okay? I'll just plug those in. I've got 1 meter times 50 newtons, and the sine of 90 degrees is 1, okay? Now if I solve that, I just get my torque is 50 Newton meters. Okay, pretty easy, pretty straightforward problem. Once I figure out how to apply all of these values from my equation into there. Let's look at one that might be a little bit more challenging. Now let's say we've got a merry-go-round and we're pushing a small merry-go-round. The radius of that merry-go-round is 1.5 meters, and I'm pushing it at an angle. I'm not pushing it tangentially. I'm pushing it at an angle that if I calculate the force angle with the center to the axis, I get an angle of 110 degrees. Okay. Well, again, I have my my radius. So if I say torque equals radius times newtons times the sine of theta, again, I can just put in my numbers and I've got 1.5 for my radius. I've got 50 newtons. And the sine of this 110 is going to be 0.94. So if 1.5 times 50 is 75 times 0.94 is 70.4 Newton. Oh, I forgot my meters there, right? So let's go ahead and add that. And again, this is quite common where you kind of work through a problem and then you forget a unit. So just put it back in there. Newton meter, and that Newton meters is the unit of torque that's applied on that merry-go-round. So these are the two different types of problems that you'd have, and you can use them using this formula once you can figure out the way things go into that formula to solve for torque.